Hi, here's our stuff for Wednesday, day number 62, and we're continuing learning how to factor, which means rewrite stuff as a product, as a multiplication process. Some refreshers at the top, something to a power times something to a power. I'm hoping this is becoming automatic for everybody. That's where you add the powers, add the exponents. Power raised to a power is where we multiply the exponents. So m times n there. And then there's this other real important pattern to know. If you have the same two things in both sets of parentheses and one says plus and the other says minus, you always get the square of the first thing, take away the square of the second thing. Notice the order does matter. The order is the same as it is there because it's subtraction. Order matters with subtraction. We're going to be using this going in the other direction very, very soon. This is what we did yesterday. I'm going to factor out the GCF here. For 16 and 20, we can factor out a 4. And we've got x's in both places, so we can factor out an x to the lower power that we see, x to the first. Same is true for the y's. We can factor out a y to the lower power, y to the fourth. Now what gets put back? 4 times 4 to make the 16. X times x to the fourth to make an x to the fifth. We do not want to put a y here because it already has the correct power. Well, we make that 4 look a little more 4-ish. Then plus, we need a 5 to bring back the 20. We do not want to put an x there because it's got the correct power right now. And we need a y to the third. That'll make the y to the seventh come back. Okay, so if you multiply this out, if I didn't mess it up, you should get back exactly what we started with. Let's do one more, then we'll move on to the next idea. 35 and 25. 5 is the best we can do there, right? We got an A and an A, we'll go with the smaller power, A to the 5. We got an M and an M, go with the smaller power, M to the first. We got a C, we don't have a C there. We got a P, but we don't have a P there. So this is the GCF, that's the best we can do. We need a 7 to get the 35. We do not want an A, we do want an M, and we also want a C. There's 35. A to the fifth, M to the second, C. Same original term. And then 5 times 5 would make the 25. We need an A to get an A to the sixth. We don't want an M. And we need the P to the third thingamajig. And there we go. There's our answer for that. Okay? And we saw some of these yesterday. Binomial greatest common factors. The binomial greatest common factor, this first example is the expression x plus 6. So it's x plus 6 times that plus x plus 6 times that. So as I rewrite this, I just write x plus 6 times what goes in these parentheses, the x squared plus 25. If you multiplied that out, you would get that first term plus multiply that out, you get that second term. Strange looking, but you're going to see how we use it very soon. It's very useful. What's the common factor here? The 3w minus 7. I write 3w minus 7 times, and what's in the other set of parentheses? The 2w minus 9. Okay. Now, moving down here, and you see the word whoa because we've got strange goings on here. These do not exactly match, do they? They are related though. This is the reverse order of that one. This says k minus 3, that says 3 minus k. So what we can do is use this idea here. 3 minus k could be rewritten as minus 1 times k minus 3. So let me go down here. Let me push this idea and challenge your patience just a little bit. Instead of 3 minus k, I'm going to write minus 1 k minus 3. I'm doing that to make these match. Now what can I do in here to make life simpler? It's going to be take away -5 times this if I, multiply this out. So instead of take away -5, I'm just going to change that to +5. So what happened here was I reversed the order, which is kind of like multiplying by -1. And then I reverse the sign here, which is kind of like multiplying by -1. Now what happens to any number if you multiply by -1 and then multiply by -1 again? You get back the number you started with. So we didn't break any rules, we didn't change any values, but now we have a matching common binomial term of k minus 3. And I can write k minus 3 times w plus 5. That's one of our new tricks for today. Go over here. See a similar situation, m minus 2 compared to 2 minus m. So I'm going to reverse this subtraction, which is like multiplying by -1. And to make it legal, I'm going to reverse the sign here, which is like multiplying by the -1 a second time. I change this to m squared, m minus 2 minus 7, m minus 2 instead of the 2 minus m. And now I've got a match, and I can write m minus 2 times m squared minus 7. All done. And that brings us to where we can now try something called factoring by grouping. Notice for these terms, there is no common factor with the numbers or with the variables. There's no number that goes into all four numbers, and we don't have an x at the end. But what we do when we do factoring by grouping, and we do factoring by grouping usually starting where we see four terms, like we got four terms here, right? We take the first two and the last two independently at first. So looking at these two by themselves, what common factor do we have? Nothing with the numbers except a 1, useless, but we can factor out an x squared. I can write x squared times 2x would make 2x cubed, and then minus 3. See, there's 2x cubed minus 3x squared, written differently. Then these two independently, do you see a common factor there? How about a plus 4? I can write plus 4 times, what do I need in here? To make an 8x, I need a 2x. And to make a minus 12, I need a minus 3. So there's 8x minus 12 written that way. Now, what do you notice? And this won't always happen, but usually it will happen with the exercises we're given to practice factoring by grouping. We get this common factor, and we can do the same thing we were doing a minute ago, right? 2x minus 3 times x squared plus 4. Pretty neat, eh? Let's try one more. No common factor across all four terms, but if I group that group of 2 and that group of 2, let's see what happens. I can factor out an x squared times 3x to make the 3x cubed, and then minus 4. There's minus 4x squared. And from these two, let me factor out a minus 2. Minus 2 times 3x would make the minus 6x, and minus 2 times the minus 4 would put back the plus 8. And there's the match that we were sort of expecting. 3x minus 4, x squared minus 2. And that's it for page 1.